Strong application performance in a random world webinar. Before we get started, I'd like to go over some general housekeeping items. All attendees are in listen-only mode, but can submit questions at any time through the Q&A feature. To keep the momentum going, we will address any questions at the end of the webinar. We will also send out a copy of the presentation to you after the webinar. Lastly, please find us on Twitter with the hashtag ConsultCollab, which is located on the bottom right-hand corner of the slide. We hope to hear from you. Our speakers today are Walter Coquette, Chief Technology Officer, Collaborative Consulting, and Mark Lustig, Senior Director of Collaborative Consulting. Walter is a pragmatic technologist and is committed to applying technology for business value and advantage. He has defined Collaborative's flagship performance engineering methodology and continues to work with the team to expand its capabilities and services. Mark has solved challenging performance issues for numerous Fortune 500 companies across a breadth of industries, notably financial services, insurance, and healthcare. In addition to being a hands-on performance engineer, Mark specializes in application and technology architecture for multi-tiered internet and distributed systems. Walter?
Thank you, Melanie. So here we are today, Monday, December 1st, after Thanksgiving Day and Black Friday. And already we had, as you can see by our main slide here, we had a couple of systems that experienced unforeseen volumes and stability issues. One of the more significant ones is Best Buy. Their site had intermittent problems during the day for Black Friday, as well as we found out some of the traffic was generated by web mobile devices, which was much more volume than they had anticipated. So hold that might be a test case to think about later. We want to talk today about high availability, and really fault tolerance is what it's all about, building systems to support high availability. And ultimately really play on the theme of chaos, right? Today's systems are just huge, very interconnected and driven by extreme events, whether from, as I mentioned, Black Friday. Certainly social media can drive traffic that you didn't see. And more recently, we had the John Oliver effect when he helped shut down the FCC site. So just a brief review of our agenda today. We're going to spend some time on some more examples of high volume coming into your websites and systems in general. We don't want to forget distribution centers and warehouses. We want to talk about how do you work with your business to better set expectations, right? How do you get your business involved around availability? What should availability be? And what should some failover or outage limits be? Can the business tolerate 10 minutes, for instance? Then we believe that leveraging performance engineering can get you to a DevOps culture. Many organizations are trying to start with it. And what better place than performance engineering and testing, where that crosses many, many boundaries. And as we know, DevOps is about removing boundaries and breaking down barriers. We touch on the infrastructure that's really key to having successful high availability and fault tolerance that your application will be built on. Then your application needs design goals and development goals for availability and performance targets that the designers will design the system for. We want to enhance our performance testing capability. We really are, last year ourselves at Collaborative, I know Mark's team has done a bunch of work around more robust performance testing around failover and availability while under load. Then going into production, how do we monitor this proactively, right? These systems need to be monitored if you're going to get ahead of it. How did Best Buy know that their system was unavailable and why? And then ultimately, your team needs to react quickly. How do you solve this problem? How do you get to the bottom of it quickly in production? And it's really about, there are planned events and unplanned events, we all know. You know, for instance, John Oliver, funny guy. Now we have the John Oliver effect. I think we're going to move off our Black Swan event and focus on John Oliver. You know, he did point millions of people at the FCC website, which crashed for comments. Granted, it's not a transactional system, but I think that gets to where things can come from out of left field. Certainly, an unplanned event. Again, Google, the double-click problem that affected thousands of websites. You know, your website may link into this. How do you design for that? If that third-party link is unavailable, what is your site what is your application going to do without that?
And just some interesting comments on the double-click reality. Given the preponderance of ads that are included in today's sites, not only were 55,000 sites affected, but they weren't all actually affected in a bad way. They were affected in a bad way that didn't have their ads, but in many cases, the sites performed quicker and faster because they weren't loading the third-party ad content. In the worst cases, the sites went down completely because the pages were completely dependent on every element within the page, including those ads. So carefully building the pages to handle those third-party components is something we'll also touch on.
Excellent. And again, the social media theme here, we had Mercedes-Benz linked up Facebook and Instagram to drive significant more traffic to their website in order to get recognition. So your business is thinking of new ways, and your marketing team is thinking of new ways to drive traffic, and hopefully the IT department is in sync with that. You don't want to find out about a 50% traffic increase the day of it if you weren't aware of it. And then, social media just continues to influence what's going on, right? Paper had a big hit there with the Break the Internet campaign based on social media here. And again, those are more planned. They knew that was coming, and that gets to your scalability issues, scalability design. JetBlue, it even happens to the best of us. Again, booking your trip. This one can force you into a competitor. If JetBlue's unavailable, you're going to go to United. Is this a quick glitch and you're back at it, or how does JetBlue handle the outage and get you back so that they capture that? So it can, we all know, website performance and availability will impact the revenue for the business.
Yeah, it could definitely impact your reputation because your online presence and your systems presence to its users, whether they be online or whether they be folks on a factory floor in a distribution center, certainly affects the user's expectations.
Oh yeah, and Mark, to your point, the reputation. If you just Google today, right, that not Best Buy, but if you Google website outages Black Friday 2014, Best Buy is all over the place. Even though there were other sites that were down, HP Store was down intermittently, and part of that was because they had problems with their own internal cloud, right? Foot Locker was down, Melanie pointed out earlier today. DoubleClick we talked about, Cabela, the sports outlet, was down, so it can definitely impact your brand for how you're perceived, and we certainly know your brand gets impacted if you're the government, healthcare.gov.
Yeah.
Set some expectations, Mark.
So really the first step to beginning to address this problem and proactively handling chaotic events is really working with the business and understanding their expectations. So this is just a kind of a comical example. The Game of Thrones TV show is set certainly in a specific way, and users have a certain expectation of the kinds of plots and culture. But if the user was different, if it was Disney who was building that, obviously the environment would be quite different, and the set would be quite different, and the dialogue would be quite different. But understanding what those users are, working with the business itself, requires some negotiations and expectations setting, both for not just what the system's supposed to do, but what it's supposed to do and how it's supposed to do it, so those non-functional requirements. Really the first key step to setting those expectations is to understand what sort of service level objectives need to be set. So there's certainly different types of activity, different types of usage patterns, different numbers of users, different definitions for what a concurrent user is, because if there's 10,000 concurrent users on the site, does that translate to 10 transactions per second, or does it translate to 100 transactions per second?
That's a key point, Mark, as well. Also today, certainly in 2014, where it's coming from changes, needs to be part of this. Not just the browser, but your mobile site, right? That's what really crushed Best Buy, was because the mobile transactions took a lot longer to complete than they had modeled it after.
And there's also other things that are going on against the system itself that you need to be aware of. In today's web-facing companies, there may or may not be a batch process that's running in the background at certain times of the day. But in most enterprise companies, you're certainly going to have that batch window that the system needs to be aware of and handle.
Yeah, and that's a key point. This is, Mark and I have been doing this for a while, and batch is constantly there in large Fortune 500 companies, and it is often underserviced. People don't understand how long the batch is going to take. They don't understand that you need a cushion, right? If you have 4 hours to process 500,000 sales orders, you need to do it in less than 4 hours. So putting those goals out there is critical as well.
Yep. And planning not just for the current peak, but planning for what the forecasted peak is going to be. So that requires really an understanding of what the system needs to do today and what kind of growth is the business projecting. So an interesting example, I had an opportunity to hear from Auto Trader back when they were doing their Super Bowl ad. The first time they ran their ad, all the increase in traffic around the Super Bowl commercial brought their site down. The next time they ran their ad, they got much more proactive. They did much more informed testing, planning for those peaks, and their system was able to support that load. So really understanding what those users are, working with your business, understanding what kind of marketing events is really a critical first step. And then what kind of availability needs to be there. So this is something that you've probably heard of, the 5 nines or 6 nines expression. What does it really mean to be available at 4 nines? And what kind of downtime can you really have? And 4 nines, you can have within 90 days only 8 seconds of downtime, or only 32 seconds of downtime over the course of the year. That's really very little time.
It is, and that's good to make the business aware of that requirement, right? And as a performance engineer, communicating to the business what that might take, right? Is it worth the business to have 8 seconds of downtime, or could they support 10 minutes of outage and still get going?
And then as we get to 99%, it gives us a little more flexibility. We now can have maintenance windows. We now can be down 3.5 days over the course of a year.
And along with availability goals, this is a high-level methodology that the performance team here has used, a collaborative, to help walk the business through setting performance expectations. We call it our 3-pillar approach, where really is in the business context, what is the workflow of the business, and what could the business tolerate in terms of an online transaction response time is the first one. And then certainly the second one is the user perspective. So users today expect it to be faster and faster and faster. And how do you balance that with the business needs? Also, many of our clients implement with third-party vendors as part of the solution, whether it's a distribution center, warehouse, website, even messaging and middleware. What is the vendor's perspective on achieving the response time? You don't want to be in a situation where you tell the vendor to do something that's extremely difficult to achieve, for instance, 500 milliseconds. Mm-hmm. So though different industries, right? Brokerage is pushing into single milliseconds in order to get faster and faster. Then we take that as step 2 and really negotiate what are the objectives. So how do you work with your business to get to that rating that says we need 3 seconds for peak hour, and the business understands how you got there. And we tend to do it in a use case scenario as well as overall system. Critical use cases need to be identified that may have extreme performance requirements. Maybe a shipment notification, an email notification, and a real-time pricing inquiry to your other system may have to respond within 500 milliseconds. And then ultimately those become your design guidelines for the builders of your system. In today's Fortune 500, there are many people building systems, right? It can be outsourced, it can be insourced, it can be a hybrid. And they all need to understand what those business design goals are from a performance perspective.
So yeah, going back to the Game of Thrones theme, understanding what that peak demand on your application, again, takes negotiation and collaboration with the business users, and understanding, from not only business but also marketing, what kinds of things are going to drive that overall peak demand. Is that demand going to be 1 to 10 transactions? Is it going to be greater than 10 transactions per second? How quickly are those metrics moving? And anyone who's dealt with performance understands that at some point, if there's exponential growth and demand on the system, that peak is going to increase so quickly that the system needs to be built in a very robust manner in order to support that. Otherwise, there will be an outage. So the example of Best Buy not planning for some of those mobile long-running sessions is an example of some exponential peaks in traffic.
And it's also marked through the HP store. While their front-end website handled it, the middleware back-end cloud system that they had in place was unable to handle this improved load. So there you have a website that could handle, for instance, 10 transactions a second. But the website communicated to a downstream system that could only handle 5 transactions a second, for example. So there's a bit of a mismatch in being able to find those that says that you can monitor and trend those moving variables quickly to see when you're in trouble.
And that gets the importance of understanding the distributed architecture itself, and like Walter said, the downstream effects. We've seen enterprise clients of ours, when there's been, in the financial services space, an increase in market activity, the effect that it could have on the back-end mainframe systems that are actually handling transfer activity between different accounts. So all
the brokerage, that's a key one. Also the pending orders, right? There are conditional orders that are sitting out there waiting to execute, depending on the market movement, that can greatly influence your volume as well. Absolutely.
So there's sort of some known influencers, but there's been an emerging trend, certainly in the last 10 years, around the different kinds of unexpected events and the impact of different avenues, different channels that really didn't exist 5 to 10 years ago. So this first graph on the left is really showing, and this is only about 2 weeks old, what kind of email traffic retailers are sending within 60 days of the Black Friday event. And if you look at this pattern, basically 2 months before Black Friday, they're starting to send teaser emails going, we're going to have a Black Friday sale. And that's been an increase in activity. The trend here is that in the last 4 years, the frequency of those teaser ads has increased quite a bit. Whereas in 2012, there was 2, 60 and 60 days out. Now in 2014, they're doing 58 days, 53 days, 43 days, 35 days, just an increase in activity that is driving more and more expectation and creating what we like to call sometimes flash events, where everybody's finger is on the keyboard at midnight, or land rush type events, which is obviously what the retailers would like to generate that traffic, but certainly is very, very difficult to plan for from a performance point of view. There's also the impact of social media, and really the trend in how people use social media today. 71% really are more likely to purchase a brand that they follow online, so they'll sign up as a loyalty subscriber to a particular retailer, and they'll get coupons sent to them via Facebook, via Twitter, via other avenues of social media, and all those kinds of things are just driving more and more traffic to different types of sites, notably in this case retailers. But there's an overall social media effect that is trending quite a bit. And here's 6 of the largest social media sites and companies. Certainly Twitter, Facebook, LinkedIn. Everyone's receiving tons of emails on a regular basis from these types of companies. So just some things to highlight on here. 5,700 tweets per second. And if folks don't believe that Twitter is certainly having an impact on the way that we execute online and the way that we purchase things, I mean, all you have to do is look at that kind of number and look at the kinds of things that are trending. And certainly the John Oliver example took on a life of its own on social media, because not everybody who hit the FCC site was watching the show. People started to get links to try and do that.
Yeah, and that video was on certainly YouTube, available for people to see and check it out again. So the lingering effect of that.
And then just the other aspects of all this increased demand and traffic on the infrastructure of the internet is really challenging overall bandwidth and throughput. And really, any one company's dependency on that shared resource, that big cloud out there, and being able to predict when there will be storms and when there won't be storms, really becomes a challenge. And the DoubleClick example is a perfect example of that, because when DoubleClick is unavailable, that affects a lot of the content delivery networks like Akamai and their ability to serve up content effectively, because instead of having things cached, they're now having to go back to the actual third parties themselves and do more dynamic transactions. So that increase, it's really has a ripple effect throughout the whole internet. Well, just focusing more on today's businesses and different types of businesses, obviously we've talked a lot about retailers, but what other kinds of events are peak chaotic events? Insurance companies, whether they be health insurance or prescription benefits insurance, open enrollment is typically happening on an annual basis, and that's considered a huge peak of activity for those types of companies when all the participants and subscribers to health plans are renewing their benefits within a defined window, whether that be a week or a couple of weeks. On the factory floor, there's certainly peak events that affect a company's ability to actually deliver and ship their inventory out to their consumers. So the impact there, while those users aren't necessarily using the web, they're using things like barcode scanners and interfaces within the distribution center itself. If there's any impact to the system's performance, that will actually prevent things from shipping on a regular basis and prevent the bill of lading from getting calculated efficiently, and could actually cost companies significant amounts of time and money by just having that inventory sitting idle in their centers. Anything you want to add on the pharmacy side, Walter?
Well, the pharmacy, their events are around cold and flu season, or maybe swine flu occasionally, in order to shift their demand. Again, how do they scale for that? So, yep.
So we've talked quite a bit about the business users themselves, but how do we handle this internally? How do IT organizations handle this? And how have they done it classically, and what sort of emerging trend are we seeing here? And typically, there's a lot of finger pointing if there's a problem. There's a challenge in clear lack of ownership and clear ownership of resolving issues, because now we've got shared architectures, shared infrastructures that have to be scaled in order to handle and perform and support those peak loads and those unforeseen loads. Assuming that scaling is the infrastructure's problem or root cause analysis is the operations problem, is requiring everyone to sort of work together in a way that they haven't necessarily before. So problems aren't getting resolved as quickly as they need to be. So someone really needs to take ownership. That culture needs to change. And what we've seen in the last 3 to 4 years is this idea of what everyone's referring to as DevOps, and the intersection between development and operations, which spans the full life cycle, really requires a collaboration between the development teams and the operation teams that requires a level of maturity and agility that is happening successfully at many of the smaller web-facing companies and is starting to happen slowly within large enterprise companies. And our view on this is that the performance engineer is really a key enabler, and they span both the development and operations groups, because as the performance engineer works to make sure that the service levels and non-functional requirements are defined early in the process and that they get built into the system as it's getting developed and tested using performance tested and monitored once in production, that performance engineer is really one role that spans the full process. So it's an exciting trend that a lot of companies are starting to grasp and work closely around, and it's really forcing maturity into the organization that spans really multiple stakeholders. So the operations teams, which include folks from all the different types of infrastructure and development platforms and the operations centers, the development teams across all the different components within the distributed architecture. It's not just limited to the IT organization that you're a part of. It's also other aspects of the business and other third-party companies. So those systems integrators that you're working with, maybe there's an outsourced data center provider. If you have components in the cloud vendor that you're working with. So this then brings into play the vendor management folks, because as you're working with your vendor management organizations to work with those third parties, there's contracts that are in place that have to be accounted for so that the contract can be modified in order to support this maturing of overall resolution of issues. And see on here, the notorious 40-person triage call. We've just seen time and time again when there's production issues or performance issues, the call, ensuring DevOps and really pushing down this path and working more closely together, we can work towards making things more efficient, but also eliminating the unproductive 40-person triage call and getting more towards the targeted resolution.
Thanks, Mark. It really starts with the infrastructure, but today, 500 companies is just crazy. I mean, they have certainly large investments in on-premise systems, right? They themselves may have multiple data centers across the U.S. or even globally. Let's just take an example of an inventory system, right, for a particular warehouse or a few warehouses. It's on-premise. And then you factor in hosted vendor applications. That was a big trend. Part of the application left the building, but it went to a specific vendor who would host your software, and you had to allocate hardware and all of that. Then certainly we have cloud is influencing now an option for us. So your cloud application may still need to get to the inventory system. And then there's the hybrid private cloud that's within, kind of in the business, kind of not in the business, not four walls, it's out there. So just get a handle on the infrastructure and then layer on high availability and performance. When you get to your hosted vendors, how do you hold them accountable for high availability? Is that in your contract? Mark mentioned contracts and vendor management in a prior slide. Is it written in their contract that it's 99.999 in 3 seconds or 8 seconds of outage? And how do you enforce that? It's very important.
And we worked with a company, and it used an analytics vendor that was a third-party vendor, and all those analytics tags within their page itself actually got routed out to that third-party site. And if not built correctly, it was actually a synchronous call. So you'd be waiting while you're rendering your web page for the analytics to actually get routed to that third-party vendor. And as we looked into their service level, it was almost a second, which was allowed there. So the way that we proactively handled it in order to minimize the impact was to make that analytics tag asynchronous and not part of the core transaction.
There's just a big, highly available site from our friends at Rackspace. Full duplication of the sites in order to achieve high availability with clustering within the sites, load balancing across it, really spread out in order to achieve high availability of your infrastructure. And then certainly data is a big challenge when you're dealing with an infrastructure and replicated systems, whether they're active-active or active-passive, how the data gets moved across, whether you do data partitioning by clients or customers, that all has to factor into your design for high availability.
And we've talked a bit about infrastructure, and there's certainly a role there. And there's ways to automate handling that failover and ensuring that there's a level of business continuity for the system itself. But there's certainly some key application considerations that have to be built into the application itself and how you designed it in order to support some of the business objectives. So if you have the requirement for session-level failover, meaning that if I start a session and some component of the infrastructure goes down during my session, I don't want to lose my state. So one way to handle that proactively is to persist a session throughout the different aspects of the transaction itself. So if you're filling out a form that's multiple pages, for example, persisting that as you work through is a classic way to handle that. But there's also a number of technologies that can enable this for you if built into your system architecture. So, via some of the Java technologies and the Microsoft technologies, and certainly a number of the ERP technologies, having those things that are built in place, it requires more proactive design, but it certainly comes at a certain impact to performance, and understanding that impact of those architecture decisions is key as you're designing that system in order to support it. And if you haven't factored in these unplanned events, then it can have tremendous impact because of some of the potential overhead associated with that type of session persistence.
On this slide, the synchronous versus the asynchronous is key. Knowing how to build resiliency into your application, taking advantage of asynchronous transactions or messaging systems, really help enable your application to better survive in the wild.
Yep, absolutely. And we touched a little bit about this, the third-party components and their effect on the system itself. So as we've gotten more social media aware as companies, and having those links within the pages themselves in order to tweet out or to post on Facebook or those sort of aspects, having that within the page itself has an impact. Having the double-click ads on your page has an impact. So there's certainly certain things to be aware of when you're designing and factoring those in as requirements. So we talked about what the stakeholders need to take into account.
And Mark, on that third party, another example is in the warehouse, right? If you send out an acknowledgement to FedEx or UPS, and you have to wait for that third party to come back and tell you that they're going to pick the package up or not, those systems can get overloaded as well, and that your system needs to plan for that. So really, to your point, it's from the web page all the way down through the factory floor into the distribution center. All needs to be considered and really understand the business scope.
Yep. Yep, absolutely. And just touching on some of the web technologies, because this has been where there's a lot of automation. There's appliances out there. The CDNs themselves are promising to accelerate your pages and your rendering time. There are certain design considerations that have to be observed in order to support that. So certainly asynchronous loading, putting third-party non-critical components at the bottom of the page so they're not fired as part of the onload event. Those are key techniques, and really understanding when the page is usable. I'm sure everyone's experienced the example of going onto a page, and as you go to put something into a search box or some sort of an entry box, and you start typing, and the page suddenly rearranges. When that happens, it really has an impact on the usability of the page itself. So being aware of how the system is designed in order to make it more usable more quickly is a key consideration in those web-facing technologies. And as we've touched on in the distribution center model, the user is using a barcode scanner and can't wait because they have to pick so many packages per hour. And they have to get the inventory packed onto the truck, and the truck can't afford to be sitting around while it's waiting for that bill of lading to be generated. So there's challenges that span both web-facing and enterprise. And one area that we really put a big emphasis around is testing for these kinds of events, and putting in place the key considerations to really performance test for these chaotic type events.
Yeah. And this is the biggest change that we've seen in the last year to 18 months in performance testing. You have to be including chaotic testing. Going back to Netflix, right? They introduced when they went to the cloud, they introduced their chaos monkey, right? They call it now their simian army that tests their site in the cloud and takes certain things out. And we've certainly been doing that for Fortune 500 companies to design, a simple goal of what happens if that third-party connection, either internal or external, suddenly takes 500 milliseconds, used to take 100 milliseconds. Knowing, those types of scenarios and how it's going to affect your business to really get that in front of you before it happens and you have to react and didn't understand it. Increase mobile use. If suddenly 50% of your users are now coming in from a slower mobile connection than that used to, that's going to present a problem for you. In test cases, you can also take out and fail over and fail back, drop some of the instances in a cluster, right? Fail it over and see what happens. So, this is kind of the test approach. Define the workload under peak, confirm the metrics. We want to monitor response time or maybe throughput. Create those test cases with the right tools. SOSA from a web testing perspective, Dynatrace has a tool for web testing, LoadRunner, of course, for scripting. And then run these tests, grab the results, and do the analysis and understand the impact of instability to your application, right? Everybody knows it works, the happy path, they say, but how bad does it perform when something goes wrong to your system? And, this is just trending a performance test, right? When the spike arrives, the response time has some problems. It crosses 20 seconds. Database statistics show some issues, and, of course, the old CPU red lines of things as things ramp up for the performance test. So really understanding what you're getting from a performance test and how to apply it is very important. And this, go ahead, Mark.
I was going to say, really understanding not just the impact of the performance test, but what we like to call the safety zone. So folks are probably familiar with sort of the app index, the AppDex terminology of satisfied users, tolerated users, frustrated, and abandoned. And what is that metric for your system itself? When do users get what they need to get in such a way that they continue to be satisfied and tolerating that system and aren't complaining about the actual response time or usability of the system itself? That workload, not just the predicted peak workload, but also the chaotic workload, really needs to be understood so that you can identify what this safety zone is for your major transaction types. So as your system is up and running, you can manage and monitor against those targets so you can be proactive. And really that gets to the next key step, which is really proactive monitoring and alerting. And one of the nice trends in the last 10 years is the systems management vendors have really worked to increase their functionality by implementing what's referred to as application performance management capabilities into their overall systems management tool sets. And this really gets to the different types of users that are accessing the system across every component of that system and being able to put together a picture of the end-to-end impact of a transaction on overall response time as it works its way through the overall architecture. This includes a number of key aspects, including what the users are experiencing themselves, but really allows you to identify and trend and understand every aspect of the transaction as it works its way through that architecture. There's certainly a throughput curve that can be graphed, what happens and what is the overall system's ability to support that light load, the moderate load, how does it handle that heavy load, and what is that saturation point. And understanding what that saturation point is when the system becomes unstable is key to being able to manage that proactively and effectively, whether that means bringing more infrastructure online in order to support it, or whether that means getting proactive about managing user expectations and actually putting up some sort of a way to manage a user's ability to come in by throttling what that workload is. So those are all key techniques that can be used in order to ensure that the system itself remains stable and remains available. So it's just some elements of APM, highlighted by Gartner. End user experience monitoring is really the ability to capture for every single user how long their user experience is. The runtime application discovery component is the ability to actually draw a map almost automatically by putting the necessary tool into your infrastructure to see where all the transaction goes, whether it goes into the main components that you're aware of, or whether there's potentially some sort of a test environment that was misconfigured that's part of your architecture. Understanding the performance and behavior of those user-defined transactions themselves. What's that end-to-end breakdown? And then when we talk about deep dive, getting into the specifics, what's the Java call stack look like in this environment, as an example. And then the ability to do analytics, historical and real-time, against those metrics so that you can, again, much more proactively manage and perform root cause analysis, which really leads to the next component.
All right, that's right. After you do all of that, you still need to be very good at root cause analysis because things still can go wrong. And so what we'd like to do is talk about the components of root cause analysis, right? You need the right technology, and in this case, the APM tool to be able to quickly do real-time deep dive, as well as executive dashboards, so you can see it before they do. You need the right people to understand who they are, what their skill sets are, and who's needed to lead root cause analysis. You know, you need a performance engineer, you need the right tools, and there may be another small team to do that. You need the right process. Collaborative, we've put together the software performance engineering body of knowledge. It has 5 key knowledge areas, and that has been critical in helping accelerate the root cause analysis process, as well as bring the competency of performance engineering into our clients so that they understand that, and then ultimately help you prepare for a DevOps culture by crossing those boundaries. And this just shows how to formalize it. It is a formal discipline to root cause analysis, the old fishbone diagram that walks you through what the likely causes are and some of the outcomes, and ultimately, you know, get you to what that root cause is or likely candidates of the root cause analysis. And here again, just the tools showing how deep dive you can get in terms of down to the line of code, down to the SQL queries, going in by which ones are taking the most time, quickly get you in there. And these can even be pushed into your development tools, where this can be captured and handed over to the developer. The full stack trace and the full call trace and all the deep details that they need to do their root cause and fix it can be captured as well and handed over to the developers.
So really, reacting quickly, being more agile, supporting aspects of continuous development and continuous deployment are key tenets of a DevOps culture. As we're talking about accelerating root cause analysis and doing triage, those tools like the APM tools certainly help us enable us to do that more quickly. But there's other aspects that are a bit less technical and more process-based. How do I get access to a system? How do I get the right tools in place on those systems without having to wait weeks? In large organizations that are less flexible and less agile, getting changes to actual server configuration.
That's why that is highlighted in the performance testing and engineering group. And over the years, we've been dropped in to fix performance tests that aren't going well. And the first thing we notice is it's taking too long because it takes 2 days to change any database settings, for instance. The performance test team would fill out a form to ask for the Oracle SGA to be changed, and then wait 2 days. And then the performance testing schedule would be blown out of the water. So using those examples, we've proved how breaking those barriers down helps get the DevOps culture going so that the performance engineer or moving a DBA, senior DBA, into the performance testing team really accelerates changes and breaks down those barriers.
Yeah, so as we've talked about and sort of heading toward the wrap-up here, making those changes quickly, having some key things in place at the infrastructure level and at the architecture level really requires three or four key pieces here. Fault detection, the tools enable that. Certainly the fault recovery by being able to prepare and repair those issues as we've completed the triage and reintroduce components back into the system. These are the kinds of things that not only need to be handled as part of that DevOps culture, but also handled as part of the testing process. And then fault prevention, so doing different types of tests to highlight what happens when a component is offline, ensures not only that you're testing for the ability system to support it and scale, but also the ability system to remain available and resilient. And really managing those exceptions is another key aspect of really being able to ensure your system is available as possible. So we're coming up to close to being out of time, and just to sort of wrap up, we've put together just a summary sort of checklist for high availability that we sort of had as we've gone through this. And certainly knowing your history, being cognizant of the system load and what it's supported historically. So as you work with your business, set those expectations and not be surprised by marketing events and other types of things that are going to drive these chaotic events. Those are key things to be aware of. Understanding the potential impacts of social media and their influence on the workload that the site is going to be asked to perform in the potential chaotic events. Planning for extreme scenarios. What could go wrong. Making sure that you're protected against what is the least likely thing that could happen. By being creative and putting together those kinds of scenarios, it gives you a position to be as proactive as possible. Adopting that DevOps culture. Using performance engineers really an enabler to that is a key way to move that effort forward within your organization. And the last couple items, understanding the infrastructure and the architecture is key. Defining what that application safety zone needs to be so that you can manage and monitor against that and test against it, and obviously proactively monitor against that safety zone. And then the last aspect that we just discussed, the triage and root cause analysis. So, in short, really enabling your system to be and your business to be highly available and address unplanned events takes a proactive, somewhat disciplined approach, but it's really something that's achievable if you follow these kinds of steps.
Excellent. Well, since we're coming up to the top of the hour here, I will just take a few of the questions that have come in through the Q&A tool. Our first question here is, what types of tools would you recommend to help my company be more proactive with unpredictable peaks?
Sure. One of the first immediate tools to get in-house is that APM tool that can monitor the user experience. Essentially, you can monitor every user, every click, as well as the infrastructure. And the way you'd use this is to trend. So how fast is the system slowing down, if you will? As you're monitoring key business transactions, are they consistently under 1 second or hitting your goals? And then how quickly are they moving upwards if the load increases? So you want to set some alerts, some alarms to show you that, maybe it's just something as simple as the login transaction is suddenly taking longer than the average. How do you get in front of that? So the APM tools are great to jump onto from a production perspective. And they'll show your business benefit right away, right? This takes an investment. And if I can show the business that I can reduce outages or help improve conversion rates, this tool can help.
Yeah, it's a great way to leverage those tools in your performance test environment as well. Help identify issues during the development process by identifying potential issues during testing.
I feel like this next question probably comes from someone in the IT department and clearly not from a business user. They're asking, what do I do if my users won't give me a clear set of requirements for performance because they want instant response?
So really going back to the checklist there, knowing your history is a key aspect of that. So if the system exists today, hopefully it does, or a version of it does, understanding what the statistics are, the usage patterns for the historical set of transactions is one. If those aren't available, if it's a net new system with new business requirements, in order to justify that system itself, the business had to identify the advantages to really the bottom line of the company by projecting some revenue projections around that system or revenue impact around that system. So it requires really taking some of those projections or taking some of those the real actual historical data, and then modeling and extrapolating what kinds of behavior you'd expect, what kind of workload you'd expect, and then if the business is not really being realistic, managing those expectations for the business by putting a stake in the ground, saying here's the numbers we've come up with. We need you guys to buy into these numbers, and if not, we're going to go forward with these are our numbers.
Well, and the other thing to have in your back pocket is if you're a transactional website out there selling to the consumer, there are benchmarks out there from hotel industry to airlines, that companies such as Dynatrace, I think, is one that publishes benchmarks. So you can at least get more information to show them that here's what's going on in the industry to help target those.
Yeah, absolutely.
Excellent, thank you. And we'll take one more question here. We've been talking a lot about coming up with the Black Swan events, what we originally started with, or these scenarios that are least likely to happen. Someone's asking here, how do I test for these scenarios if I don't have a tool or an environment to test?
Wow. Not having the environment, I think, is one of the biggest problems to compare it to production. But you can start off slowly with component-level testing. You will need some tools. JMeter out there is a great tool to use to start the process, where you can start testing the components from a throughput perspective and building your test scenarios on top of that. But ultimately, the Black Swan or the John Oliver event, as we like to say now, you need to have an environment where you can test end-to-end. And it's put in terms of business risk, right? If you're Best Buy or Foot Locker and your site's down for 10 minutes or an hour on a peak day, that could be equated to a revenue hit of hundreds of thousands of dollars, which could justify an environment.
And from a test infrastructure point of view, if you don't have any testing tools in place, you can certainly lease some tools that are out there, but an emerging trend in the last 5 years has been the cloud-based performance testing tools, which can generate traffic globally or domestically against your site. It will require you to work with your operations department to open up specific ports if your data center is your own data center or your own infrastructure, or even if it's your own private cloud. If it's out in the public cloud, where you're leveraging infrastructure as a service or platform as a service, being able to drive from the internet may just be a matter of setting up the appropriate permissions. So it's a challenge, but there are many more solutions today than there were 10 years ago.
Great.
Right.
Well, I think that about wraps us up. Thank you, everybody, for joining today, and thank you, Walter and Mark, for your time. Have a good one.